So here's a question. If x times sine A plus y times sine B plus z times sine of C is equal to 0, and the second equation is x squared sine of 2a plus y squared sine of 2b plus z squared sine of 2c is equal to 0, then the value of x cubed sine of 3a plus y cubed sine of 3b plus z cubed sine of 3c is equal to, and we are given with the fact that x, y, z, a, b, c are real numbers, and a, b, and c add to pi. So the approach that can be taken is to somehow try to solve the two given equations to get into a more compact form, and then perhaps trying some other technique. So cross multiplication techniques that we use in linear equation in one variables can be used here. But what we can do is use some insight from complex numbers, use some insight from complex geometry. When we have something like sine of a, or sine, and then we have sine of 2a, and then we have sine of 3a. So that means we are increasing in multiples of a certain angle, and that to me looks like we are putting a complex number to the powers 1, 2, and 3, raising it to powers 1, 2, and 3. So let us define a few complex numbers, shall we? So let us say the first complex number, let us define the first complex number z1 as x times e to the power of ia. Now this is just Euler's notation. This complex number would be written as x times cos a plus I sine a. If we define a second complex number, z2, let's define it as y times e to the power of ib, and then similarly z3 equals z times e to the power of ic. Now, all these three terms, x times sine a, y times sine b, and z times sine c, all these three terms are the imaginary parts of these complex numbers. So the imaginary part of z of 1, that is equal to x sine a, and then imaginary part of z of 2 is equal to y sine b, and the imaginary part of z3, well, that is equal to z sine c. So the imaginary parts of these three complex numbers, they add up to 0. So what does that mean? That means that the imaginary part of z1 plus z2 plus z3, this equals to 0. Now let's look at the second term. The second term, in the second equation, the first term is x squared sine of 2a. Now, if we squared z1, then we can write z1 squared is equal to x squared e to the power of 2a, and that means that the imaginary part of z1 squared is equal to x squared times sine of 2a, and similarly so on and so forth. We can similarly write that the imaginary part of z1 cubed is equal to x cubed times sine of 3a. So the imaginary part of z1 squared plus z2 squared plus z3 squared, this is also equal to 0. So let me write that as well. It's also equal to 0. So now we need to find the value of imaginary part of z1 cubed plus z2 cubed plus z3 cubed. What we can do from here now is try to apply some sort of identities, and the identities that I'll apply is the following. So let me first use the following abbreviation. Let me use let's say I don't know, b sub I is equal to imaginary part of z sub I. So the imaginary part of z1 is b1, the imaginary part of z2 is b2, and the imaginary part of z3 is b3. So b1 plus b2 plus b3 is equal to 0. And at the same time, this number right now, z1 plus z2 plus z3, this is a real number. It's a purely real number. Its imaginary part is 0. And z1 squared plus z2 squared plus z3 squared, this is also a real number. What does that mean? That means that the number defined as follows, I'll just write it first and then try to explain it. This number divided by 2, this is just equal to z1, z2 plus z1, z3 plus z2, z3. This is also a real number because any operation that you do with real numbers, and you have a sane operation, that is, you're not doing the square root of a negative number, in any type of real valued function, the answer that you get is also a real number. So this means this is a real number, this is a real number, and this is a real number. Now let me bring to recall an identity that you might have encountered while studying algebra. And the identity, I'll just write it for z1, z2, z3. This is equal to z1 plus z2 plus z3 times z1 squared plus z2 squared plus z3 squared minus z1, z2 minus z2, z3 minus z1, z3. All of the numbers here, this, and then this, and then this entire thing, all of these are real numbers. So what that means is that any real valued function, again, there is a subtraction here, there is a product involved here, that also gives us a real number. What that means is that the imaginary part of z1 cubed plus z2 cubed plus z3 cubed, this is again equal to 0. That's what we needed to find. This b1, b2, b3 part, I was thinking to do something else with it, but it turns out it wasn't worth it. Anyways, the answer is equal to 0.